Hello friends, welcome to our student support program for grade 10 and 11. In today's session, we are going to look at quadratic functions. So let's start. So today we are going to learn how to find the maximum or the minimum value of a quadratic function. Remember, a quadratic function is in the form f of x, which is equal to ax squared plus bx plus c. Right, so let's consider this function, f of x, which is equal to ax squared plus bx plus c, where a, b, and c are constants. Now, let's take the first case. The first case is where a, that is the coefficient of x squared, is greater than 0. That is, a is positive. So what happens when a is positive? The graph of the quadratic function opens upward, and the minimum value occurs at the vertex of the parabola. So remember, when we have a is positive, it is the U shape. Let's see an example. Now, consider the function f of x, which is equal to x squared. Let's see, the value of a here is 1. b equal to 0 and c equal to 0. Therefore, if a equal to 1, we say that a is positive. That's right. So if a is positive, we have a minimum curve. Now, that's the minimum curve. As you can see, it is the U shape. So that's the graph of y equal to x squared. And here is the minimum value. Now, let's consider this function, f of x equal to ax squared plus bx plus c, where a, b, and c are constants. Now, for the case 2, where a is less than 0, that is, a is negative, then the graph of the quadratic function will open downward, and the maximum value occurs at the vertex of the parabola. Let's see an example. Now consider the function f of x, which is equal to minus x squared plus 2x plus 3. Here we can see that the value of a is minus 1. Remember, a is the coefficient of x squared. The value of b is 2. That is, b is the coefficient of x, and the constant term c, the value of c is 3. Now, we note that a is negative, so we have a maximum curve. Now, let's see how it looks like. So that's a maximum curve. The curve is f of x, which is equal to minus x squared plus 2x plus 3. Remember, f of x and y is the same thing. So here you've got the maximum value. Now, how are we going to find the maximum or the minimum point? Let's see. So, to find the maximum or the minimum point, what do we need to do? You just need to find the vertex. How do we do that? Well, given the quadratic function, f, which maps x onto ax squared plus bx plus c, where a, b, and c are constants, the vertex is given by the x-coordinate will be minus b over 2a, and the y-coordinate will be f of minus b over 2a. So if we need to find the maximum or the minimum point, we need to find the vertex, which is given by this formula. So, the minimum or the maximum value. Remember, the vertex gives the point. For the minimum or the maximum value, that's only the y value, that is f of minus b over 2a. Let's take an example. Suppose that we need to find the minimum or the maximum point and the minimum or the maximum value of the following quadratic functions. So, let's take the first example. We are given that f of x equal to x squared plus 2x plus 5. So, step 1, you're going to check the value of a. Remember, if a is positive, we have a minimum. So here a is greater than 0 because the value of a is 1. So we have a minimum point. Now, step 2, how do we find the minimum point? Well, we need to use the formula. So, for the x, to find the x coordinate, x will be equal to minus b over 2a. So, what is the value of b? Well, if we look at the function, a equal to 1, b equal to 2, c equal to 5, so the value of b will be 2. Now, we need to do minus b, so that's minus 2 over 2a. That's 2 times 1. That will be minus 2 over 2, which is equal to minus 1. Now, we need to find the y coordinate. Remember, y equal to f of minus b over 2a. So, that will simply be f of x. And remember, we got minus 1 for the value of x. So, that will be f of minus 1. So, f of x is given by the function x squared plus 2x plus 5. How do we do to find f of minus 1? We just need to replace all the x by minus 1. So, that will be minus 1 to the square. Remember to put the brackets. Plus 2 times minus 1 plus 5. So, that's 1 minus 2 plus 5. Therefore, f of minus 1 will be equal to 4. Now, we have a minimum point. The minimum point is at minus 1, 4. And the minimum value will be 4. Example 2. Now, we have a function f which maps x onto x squared minus 3x plus 7. So, step 1, you check the value of a. Here, a is 1. So, 1 is greater than 0. Therefore, we have a minimum point. Now, step 2, you need to find the minimum point by using the vertex method. That is, the vertex method is given by this. So, the value of x will be minus b over 2a. While for y, it will be f of minus b over 2a. So, to find the x coordinate, we just need to replace. Remember, in the function that you are given, a will be equal to 1, b is minus 3, and c is 7. So, when we replace, it's negative, negative 3. Just be careful here. That's why we need to put the brackets. So that's negative, negative 3 over 2 times 1. Remember, negative, negative is positive. So that's 3 over 2. Now, we have to find the y coordinate. Remember, the y will be f of minus b over 2a. That is f of 3 over 2. Now, how do we do that? Well, we replace all the values of x by 3 over 2. So, f of 3 over 2 will be 3 over 2 to the square minus 3 bracket 3 over 2 plus 7. So, that's 9 over 4 minus 9 over 2 plus 7, which will be equal to 19 over 4. Therefore, the minimum point will be at 3 over 2, 19 over 4. Thus, the minimum value is 19 over 4. Example 3. Now, we have f of x which is equal to 2x squared plus 4x plus 5. What can we say? Well, a is, we check the value of a for the first step. The value of a is 2. So if it is 2, it is greater than 0. That's right. So we have a minimum point. Now, how do we tackle this question? Well, we need to find the minimum point given by the formula. So, we start with the x-coordinate. The x-coordinate will be given by x equal to minus b over 2a. That is minus 4 over 2 times 2. Where did we get these values? It comes from the equation. So minus 4 over 4 equal to negative 1. We have the x-coordinate. We need to find the y-coordinate. So you just need to replace f of minus 1. That is, replace all the x by minus 1. So we will have 2 times minus 1 to the square plus 4 times minus 1 plus 5. That is 2 minus 4 plus 5, which is equal to 3. Therefore, we have a minimum point at minus 1, 3. And the minimum value is simply the y value, that is 3. We take example 4. So we have f of x, which will be mapped onto minus x squared plus 3x minus 4. Right, if we look at this function, what can we say? Well, a is negative 1, b equal to 3, and c is minus 4. So if a is negative 1, what can we say about that? Well, a is less than 0, therefore we have a maximum point. Now, what do we need to do? Well, you need to find the maximum point. We start with the x value, the x coordinate. So x will be equal to minus b over 2a. That is minus 3 over 2 times minus 1. That's minus 3 over minus 2. Remember, negative over negative is positive. So that's 3 over 2. We have the x coordinate. Now we move to the y coordinate. So how do we do it? You just need to replace. So that will be f of 3 over 2. And f of 3 over 2 will be negative. Just be careful here. You had negative x squared. So that will be negative 3 over 2 to the square. Remember the brackets. Plus 3 times 3 over 2 minus 4. And when we simplify, we have minus 9 over 4 plus 9 over 2 minus 4, which will give minus 7 over 4. So we have a maximum point at 3 over 2 and minus 7 over 4. Thus, the maximum value will be negative 7 over 4. So this was the first method, that is the vertex method. So let's now move to the completion of squares. How do we do that? Well, completion of square is simply a method that is used to find the minimum or maximum values of function. How do we proceed? Well, let's consider 3 cases of a quadratic function. Now, the first case will be where a equal to 1. The second case will be where a is greater than 0. And the third case will be where a is less than 0. Now, first case, that is a equal to 1. Let's consider this function, f of x equal to x squared plus 2x plus 5. Here we see that the value of a, that is the coefficient of x squared, is 1. So how do we do? Well, you check the value of a. We have seen that it is 1, so we proceed directly. What does that mean, to proceed directly? Well, let's apply completion of square. Now, we are given the function x squared plus 2x plus 5. The first step is you take the coefficient of x, that is 2, and you divide it by 2. So that will be x plus 2 over 2. You square it and you subtract this value to the square. That is 2 over 2 to the square. Remember to put the positive constant, plus 5. So when we simplify, it's simply x plus 1 to the square minus 2 divided by 2 is 1. So that will be minus 1 to the square plus 5. So we have f of x, which is equal to x plus 1 to the square minus 1 plus 5, which will be equal to x plus 1 to the square plus 4. Simple, right? So the minimum or the maximum point of this function will simply be minus b and c, right? So in our function that you have worked out with me, that is f of x equal to x plus 1 to the square plus 4, the maximum or the minimum, remember, a was positive, so we have a minimum point. So the minimum point will be minus 1, 4, and the minimum value is simply 4. We take another example. Now, consider this one. F of x equal to x squared minus 3x plus 7. Right. First step, you check the value of a. In our case, the value of a is 1, so we proceed directly. Now, how do we do to apply completion of square? Remember, since a equal to 1, we go directly, that is, we check the coefficient of x, that is minus 3, and we divide it by 2. So f of x will be bracket x minus 3 over 2. You close the bracket, you square it, and you subtract this value, that is 3 over 2, to the square. You don't put the negative. And then plus the constant, which is 7. So that will be x minus 3 over 2 to the square. 3 over 2 to the square, that's 9 over 4. Plus 7, you simplify it. It will be x minus 3 over 2 to the square plus 19 over 4. Now, for the minimum or the maximum, you know that already. It's given by minus b and c. In our function, we have x minus 3 over 2 to the square plus 19 over 4. So the minimum point will be 3 over 2, 19 over 4. Why is it not negative 3 over 2? Well, because it's minus b. And minus 3 over 2, that's 3 over 2. And the minimum value will be 19 over 4. Now, let's take the example where a is greater than 1. If we consider this function, f of x, which is equal to 2x squared plus 4x plus 5. Well, here we can see that a equal to 2. Right? So if a equal to 2, it is not equal to 1, what do we do? Well, we factorize. How do we factorize? Well, you put the 2 outside the bracket, so that will be 2 bracket x squared. Remember, 4x divided by 2, that's 2x, and 5 divided by 2 will be 5 over 2. Right. Now, within the brackets, we have x squared plus 2x plus 5 over 2. Here, if we check only within the brackets, well, we can proceed directly. So that will be 2 outside the bracket. Inside the bracket will be x plus 2 over 2. Where did we get that? Well, we take the coefficient of x and we divide by 2. So that's 2 over 2 to the square minus 2 over 2 to the square plus 5 over 2. And when we simplify it, what do we have? Well, 2 over 2 is 1, so that will be x plus 1 to the square minus 1 to the square plus 5 over 2. Remember to put the 2 outside the bracket. So minus 1 plus 5 over 2 will be 3 over 2. So that's 2 bracket x plus 1 to the square plus 3 over 2. Removing the square brackets, we will get 2 bracket x plus 1 to the square plus 3. That is 2 times 3 over 2, which is 3. So A is positive. We have a minimum curve with the minimum point, that is minus 1, 3. And the minimum value is 3. Example 4, that is where A is less than 0. Let's consider this example. Well, we have a function where f of x equal to minus x squared plus 3x minus 4. Right, so you check the value of A. The value of A is negative 1, which is not equal to 1. So what do? Well, you're expert now in that, so we factorize first. That is, you will remove the negative 1 outside the brackets. So that's negative 1 square bracket x squared minus 3x plus 4. Just be careful here, you need to change the sign. So complete the squares. That will be negative 1 square brackets, bracket x minus 3 over 2 to the square minus 3 over 2 to the square plus 4. And when we simplify that, we shall get negative 1 square bracket x minus 3 over 2 to the square minus 9 over 4 plus 4, which will be negative 1 bracket x minus 3 over 2 square plus 7 over 4. Now, just be careful. You need to multiply with the negative 1 because you need to remove the square brackets. So the function will be given as negative bracket x minus 3 over 2, close the bracket, square, minus 7 over 4. So A is negative, we have a maximum curve. And the maximum point is given by 3 over 2 minus 7 over 4. So the maximum value will be minus 7 over 4. So here are some exercises for you to practice. Remember, it is important that you go through these exercises. And a few links for you to better get an understanding on quadratic function, more precisely how to use the vertex method or the completion of squares to find the maximum or the minimum point. So friends, we have reached the end of our first session on quadratic functions. We have seen together how to find the minimum or maximum curve using two methods, that is the vertex method and the completion of squares. We have also worked a few examples for you. Now, go through the exercises found in your textbook. You need to practice. Until we meet again, it's goodbye for now.